Hi, my name is Edlin Garcia, and in this first part of the lab, I'll be implementing AES Advanced Encryption Standard 256 to securely transmit messages between a server and a client using a Wi Fi network. I will also use Wireshark to observe the encrypted network traffic, and since I'm using the virtual machine instead of Raspberry Pi, all operation will take place here. So, my first step is to set up the lab environment. So, I had to download the files that I needed from Canva. So I placed it on a flash drive. So let me pass that. Let's see. It should. Yeah, there it is. Okay. Okay, here is it. Let me put it to the desktop. Okay, here we have it. So let's create the directory for these files. CD desktop, and this will create. Okay, here we have it. So I need to place this into this folder. And let's list it. Oh yeah, I need to extract it. Okay, I can remove this. Okay, let's list it. Okay, now we have, let's open that to be able to run the first demo. Okay, there we have it. Now I can run the first demo. First demo. Okay, now that that's open, I need to install all the required libraries so that it will allow me to run the AES encryption and decryption. So let's install the necessary Python library. One of these is for Raspberry Pi itself. I think it's this one. Okay, pip3 install crypto. Okay, that worked. Let's see. This one is probably for the Raspberry. Let's just confirm. Okay, both of them installed. Okay, so now this library will allow me to actually implement the AES encryption and the decryption. So now I need to install Wireshark because that will allow me to track the local network. Sudo. Oh, I forgot to install. How did I forget that and that? Okay, that's the action I'm doing. My Wireshark. Okay, now it's downloaded. It's because I forgot to type in Wireshark. I mean, install. My apologies. Let's see. Okay, finally it's finished. So let's open Wireshark. Sudo Wireshark. Okay, I need to select the loopback because that's gonna allow me to monitor the local network. Since that's open, let me move that here because now I need to run the server and the client script, but I want to verify that the client has the same server IP as the 127.0.0.1. So let's open client just to make sure. Okay, here as you can see, it has the same IP. Here we have the cipher key. This is the shared encryption and decryption key. I just wanted to show that. Okay, so now what I need to do, I need to actually open the server. So this server script will actually wait for the encrypted message. Then I need to run the client Python 3 client dot. Okay, so now I need to enter a secret message. I've entered my secret message. I'm pressing enter and now it's going to encrypt the data to send to the server. So as you can see, you can't actually see the secret message that I'm sending. The message is now encrypted with AES 256. This is the encryption right here. And the message was sent. So if you recall, Wireshark didn't have anything showing. Now you can see all the synchronous and acknowledgement, the three-way handshake that established the connection. The acknowledgement. Now you can see that the communication actually took place. And if we check the server, it should show the message undecrypted. Okay, see, my secret message was hello, the data that was sent encrypted, and they received it and they decrypted with the shared key. So that's it for part one of the lab. Just to summarize, I set up the advanced encryption standard 256 system between the server and the client. I made sure that the server IP used the local 127.0.0.1 for testings within the VM itself. I use Wireshark to show that and confirm that what was being transmitted was encrypted, and I ensured the communication was secure using the encryption over the Wi-Fi network. So, like I said, part one has been completed for the Wi-Fi security using AES encryption. Now let's move on to part two. Okay, so part two is where I'll be demonstrating how to obtain a shared secret using RSA algorithm. So this method is widely used in secure communication to exchange cryptographic keys over a public channel. So the goal of this lab, like I said, is to generate the RSA key and use them to encrypt and decrypt a secret message. So first I need to set up the environment. So let's open CD desktop, make the folder mkdir lab2 RSA. Okay, see the folder has been created. Now we need to open it. Lab2 RSA. Perfect. So now I need to actually create the private key. It's going to be for two users, Dr. Alam and myself. So Open SSL. We actually already used that in a previous lab, so we can actually just go ahead and use it. Open SSL AES 128. I'm taking my time here because I don't want to make mistake. Private dot pen. Open SSL Gen RSA dash AES 128 because that's the encryption we're using. Dash out alarm private PIM. So in the PDF, it has the passkey right beside it, but we're not going to enter it until it's asked for. That is 1024. Verify it. It has been created. So now I'm going to do it for the second user, which is myself. So open SSL Gen RSA dash AES 128. The only thing that changes in this case is the name. I'm going to put my name since I'm going to be the second user. .pem. Okay, I need to enter the passkey again. Verify 1024. And now the private keys has been created. So, like I said, these commands generated the 1024-bit RSA private key with AES 128 encryption. So we're going to do the same thing, but now we're going to actually create the public key from the private key. So let's go and do Dr. Alam's one first. So open SSL RSA in Alam private pem dash pub out alarm public pem. Open SSL RSA in alarm dash private pem. Good. That has been created. Now I'm going to do it for myself as a user. I'm going to create a public key. Open SSL RSA. Again, the only thing that changed is the name. Edlin private dot pem dot pub out Edlin public dot pem. Let me just confirm. Open SSL RSA. I'm getting these lines of code directly from the PDF from Canva. So these public keys should actually be used for encryption. Now that they're both created, now I should be able to open the text editor and edit and add my secret text. So I need to press escape and then an I, and then I'm able to actually enter my secret message. I'm going to put Belize since that's my home country. Escape. Okay, then I need to enter colon WQ escape and it should take me back to the prompt. Okay, there it is. If we check in the folder, we have the private key for Dr. Alam and the public key for myself and the private one, and we have the secret text created. So now I need to actually encrypt the secret key using Dr. Alam's public key. So I'm going to do so by entering this command. Open SSL PKUTL encrypt in key alarm public .pem and secret.txt, the name of our file, out secret that the encryption. Let me just confirm with the PDF open, because it's so easy to make mistake when typing. Okay, let's check if the encryption was created. Yes, here is the encryption. Okay, so now that it's actually been encrypted, you can actually use it to send over any like insecure channel. So now assuming that Dr. Alam has received this encrypted file, he should be able to decrypt it with the private file. So let's try that. Open SSL pkutl decrypt, because that's what we're doing, in key alarm slash private dot pim and secret dot anc decrypt. This should actually retrieve the original message. So let's see. This is that text. Okay, so now we actually just need to check if it's actually been decrypted by running cat decrypt secret.txt. Okay, so now the original message is now visible. So that goes to show that our public and private key has been successfully created, and we've used the AES encryption and these public and private key to actually encrypt and decrypt the secret message which was released. As you can see, it was successful because Belize showed. So like I said, just to conclude, in the last part of the lab, I successfully demonstrated how RSA can be used for secure key exchange. I generated the RSA key, I encrypted the message using the public key, and then I decrypted it using the corresponding private key for both users, Dr. Alam and myself. So this method ensures that the sensitive information remains secure even when transmitted over any public network. So that's it for Lab 2. Thank you for listening.